Dear students, Assalamu alaikum. Welcome back. Today I am going to talk about another topic of organic chemistry, that is hydroxy compounds. So the functional group of hydroxy group is, you can see it is OH. So when we say OH, so OH is known as hydroxyl group. Whenever we are going to name hydroxy compounds, for that the E of alkene is simply replaced with OL. Hope you understand. For example, from ethane, we can make ethanol. Only the word OL has been added after replacing E of alkane. Similarly, propanol. The general formula of the homologous series of hydroxy compound is CnH2n plus 1OH. We will apply this formula. Let's move to the homologous series. Hope you know the homologous series. The homologous series is a series of organic compounds in which two conjunctive members, they differ by one carbon and two hydrogen atoms. So you have studied, discussed with me the properties or the characteristics of homologous series. So let's see the homologous series of hydroxy compounds. Here are first five members given for you people. This will make your concept very clear. You must know the first member is methanol, and the second member is ethanol, then propanol, butanol, and pentanol. Pentanol is the fifth member. Now the molecular formula of methanol is CH3OH. Similarly, you know, between two consecutive members of the homologous series, there is a difference of one carbon and two hydrogen atoms, means CH2. So if you add CH2 to methanol, we will get ethanol. Mean one carbon will increase and two hydrogen will increase. Similarly, we have propanol, butanol, pentanol. We have already discussed the homologous series of alkanes and alkenes. These are the structural formula. In structural formula, we have to show, um, you know, the types of atoms, their bonds you have to show. So in this case, most of the students, they ignore this bond, the bond between O and H. Because why I'm telling you this one? In past papers, this type of question have been asked, like say, how many bonding electrons are there? If you just consider it as OH, definitely you will ignore this bond O and H. So if you count the number of lines, 1, 2, 3, 4, 4, just multiply by 2, it will be 8. So there will be 4 covalent bond here, and fifth one is this one. I mean, there are 5, bonding electrons in methanol. Similarly, you can find in other members of the homologous series of hydroxy compounds. This is ethanol, this is propanol, this is butanol, this is pentanol. Hope you understand. If you have any problem, you can share it in comment box, and please do subscribe my channel so that you can get notification for the incoming lessons. I'm trying to cover up all the syllabus topic wise according to CAIE, and we will be solving at least, inshallah, more than 10 years past papers with detail, inshallah, you will see. Okay, hope you understand up to now. After this, we will be talking about isomers. Hope you know what are isomers. So isomers are the compounds containing same number of atoms and different structures. Due to difference in the structures, their physical properties changes, but their chemical properties stay the same. Hope you know what are the physical properties, like say melting point, boiling point, their solubility, their uh, conduct, their viscosity, their volatility. Hope you understand. Just like alkanes and alkenes, we have isomers of hydroxy compounds, compounds containing OH group, which is known as hydroxyl group. For example, you can see from this, I have drawn isomers of propanol, isomers of butanol, and similarly, you can draw isomers of others. At least first five members, you must know their structures, their naming, and along with that, you must know their uh, how to draw their isomers. And you can be asked to, compare the properties of butanol with isobutanol, propanol with isopropanol. So let's see the isomers of propanol first. See this, these are three carbons. First, we need to mark the chain. Chain is marked in such a way the numbering has to be done from the side containing functional group. This is the carbon number 1 because with this carbon we have hydroxyl group. This will be carbon number 2nd and 3rd. So there are three members. That is why we will write the word propane dash 1 dash O. Between the, you know, before and after the number, we will have to write or show the, dash. OL is for OH. So how you can make this structure different? Just change the position of OH group. After this, you can see that this is the another isomer of propanol. I have just moved the OH group from carbon number 1 to carbon number 2. Similarly, we have isomers of butanol. This is simple one state chain in which we have four carbon atom. That's why it is known as butane 1-ol, because on first carbon we have hydroxyl group. We can numerate this chain from this side as well. 1, 2, 3, 4, but if the functional OH is not there, as OH is there, we have to prefer the side containing hydroxyl group first. Hope you understand. Similarly, these are the other isomers of, you can see, uh, 2-methyl propanol and butane 2-ol. These are the remaining isomers of butanol. Similarly, if you know the concept of isomers, then even you can change the functional group if the number of atoms stay the same. For example, in this case, you can see I have taken oxygen separate from OH. It comes in the chain like this. If you count the number of hydrogen atoms of any isomers, you will say they have same number of hydrogen atoms, same number of carbon atoms, same number of oxygen atoms. So this is how we draw the isomers. You must keep in mind isomers are very important. For example, if we see in case of petrol, you might have seen written on the petrol pump high octane. Basically, that fuel has more number of octane molecules, but those octane molecules which are branch chain like this. See, this is a branch. So whenever we have branch, you have to again number the chain, see the branch, name the branch first, like say this one, 2-methyl, Then name this compound. What is left, like this chain is left after branch has been named first. So 2-methyl propanol. Hope you understand. Propane 2. 2 is the position of hydroxyl group. If you have any question, you can share it with me. Please do subscribe my channel. Uh, Inshallah, I will go on working for you people, and inshallah, I will make you independent learner. Inshallah, thank you very much. Allah Hafiz.